if everything in the computer is a 1 or a 0, and it takes 8 bits to make a character, let's say you typed your name in, and Michael, we'll use you as an example. Your last name's about this long. And every one of those characters in his name takes 8 bits. So when you type Van Eisenbergen in the computer, once it gets to memory, there's 8 bits for every one of those. That's quite a lot of ones and zeros. So if you were going to print something out from the computer to find it, let's say there was a problem, and it wanted to give you what was going on inside memory, it's not going to give it to you in binary. It would just take too much paper. So they convert it to hexadecimal and then print it out in hex. Hexadecimal, and we're going to call it hex for short, is base 16. So what do we know about this numbering system now that we know the base?
Everything is 16.
Everything, yeah, when you start your number line, you're going to multiply by 16. 1 times 16 is 16, 256, 4,096, and on and on and on. You just keep multiplying by 16. So it gets big really, really fast. We also know that we've got 16 digits to work with. In hex, they only allow 1 character for all those 16 digits. So we've got 0 through 9. If we were in decimal, what would 16 digits be? 0 through 9, and then we'd have 10, 11, 12, 13, 14, and 15, right? That's 16 digits. Well, hexadecimal says you can't do this. I can't have 2 characters representing a number. So they said, all right, I'll just go to the ABCs. So in hexadecimal, a 10 is an A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So the 16 digits we can work with are 0 through 9, A through F. There is no G, there is no H. It stops with F. Okay. So now we can use these 16 digits to represent any number we need to. All right? All okay so far? If I ask you to take a decimal number and convert it to hex, we're going from base 10 to base 16, and I gave you the number 8 in decimal. What are you going to give me in hex?
8.
8. Because down to the number 9, everything is exactly the same. What if I gave you a 13? It'd be the number, well, letter B, but it means 13. Okay, everybody see that? Here's 13. There's its equivalent. Yes, sir?
Is that a 1 over a 0?
Is that a what?
A 1 over a 0.
I'm not sure. Oh, I started to write decimal there. No 1. This is hex. Well, it's got hex. All right, now what if I gave you 16?
No, 1.
You're on the right track.
0.
1 0.
Who said that? Okay. Look at your number line. How can I get 16 out of that number line? I need a 16, don't I?
Oh, yeah, okay.
And then I've got to hold that place. So a 16 in hex is a 1 0. All right. Let me make some more room here. What if I gave you 24? Now, there's another way we can do this besides looking up here. It's not quite as easy as it was in binary when you said what plus what is equal to this number, because we're now working with 16. You can take the number you're looking for and divide by the base. Save the remainder. How many times will 16 go into 24? One time. Okay, and what is left over?
8.
I'm sorry?
8.
8. So I'm going to put the remainder out here. 16 will go into 1 how many times?
2.
None. It won't go any, and that 1 is left over. I read it from the bottom up. So if I were to plug this in here, we've got 1 times 16 is 16, 8 times 1 is 8, and what is 16 plus 8? 24. So 24 in decimal is equivalent to 1/8 in hex.
So it's 1 remainder 8, and then you plug that in up there at the top.
Yeah. And when you do it, this is just the way I learned it. That's totally different. I mean, we normally divide and go up, don't we? But I learned to divide, and after 30 years, you can't teach an old dog new tricks, or at least not this one. So we save the remainder. Always read from the bottom up. This is the furthest left number in the number line. Let's do some more. 43. Now you could, if you're really good at math and you can do this all in your head, you can say around how many 16s are there in 43? 2? So we could just put 2 here. What is 2 times 16?
32.
32. So 32 subtract from 43. 1. So we've got 11 left over in only one spot. So what are we going to do?
Okay.
What is, 11 in hex is B.
Can you do that one more time?
Okay.
2 and B.
2B. Yeah, or not 2B. Okay, we're looking for 24. No, 43. How many times, you know this is too big. We can't go there. So go down to 16. How many times will 16 go into 43? 2 times. And then we multiply this out. 2 times 16 is 32. So we're going to take the number we're looking for and we're going to subtract that from it. And we get 11. Well, we got a ones position, so we've got to come up with something that goes in that one position. 11 in hex is B, right? Now, let's check it and make sure it's correct. 2 times 16 is 32. B is 11 times 1 is 11. Add those together. 43. Are you with me? I don't see any totally blank looks. Everybody's okay? All right, let's do another one. 158. All right. Nobody say anything, just let everybody have a chance, but convert 158 to hexadecimal. Here's where I need a calculator. You can use your phones if you've got a calculator, but only to calculate.
like this.
How many times will 16 go into 158? 9 times? Okay. With what left over?
14.
14. What is 14 in hex? So put E right there. Save the remainder right there. 16 will go into 9 0 times. So that 9 comes here and you read it from the bottom up. So it should be 9E. Let's plug it in. Make sure that's correct. 9 times 16, 144. E is 14 times 1, 158. Did everybody get 9E? No? Did I see this? No? Okay. If you didn't get 9E, do you see why you got another answer? I'm getting nothing. I don't get it. So. Okay, you don't. All right. Do you? Okay. How do you feel about division?
Yeah, I can do that.
Okay. All right. So you got this far. You got your E and you got your 9. All right. So reading it from the bottom up, we've got 9E. When we
You
plug
don't have
it
to
in,
divide like that, right? Because that's complete.
no. If you want to go up,
Oh, okay.
158 divided by 16 would be 9 here with E over there. Yeah, no, you can go up,
Okay.
and then you don't have to read it from the bottom up. You've got it. So it's however it's easiest for you. So you okay now?
Yeah, so then we did 16 divided into,
16 into 158. D8. Let me do it up this way and see. 16 will go into 158 9 times with 14 left over, so we put the E. And then we just keep dividing until we get a 0 here. 16 will go into 9 0 times, so that 9 is the remainder. So 9E.
okay, so we don't keep adding like zeros. Just leave it at that.
Yeah, no, just go until you've divided down, and the last thing is 0. Let's do another one. 296. Convert that to hex.
$2.96.
296.
What's the purpose of hexadecimal?
When the computer is trying to tell you something is wrong, it's not going to print it out in binary. So you get what's called a memory dump, and it's going to give it to you in hex. And we're talking about on the mini computers, the servers, the mainframes, and the supercomputers. For these, it'll be something different. But it tells you, it gives you what is in memory in hexadecimal.
So it'll tell you, I've seen that a lot.
Yeah, it'll say 9E, or it'll say, F3 on the memory dump.
This is because otherwise it'd be an awful big piece of paper.
Yeah, it'd be huge. It'd still be printing to dump out what's in memory to let you know. Or you can ask for, to let you know what's going on in memory at the time. You can ask for that information. You also need to know hex when you are building web pages. For colors, sometimes you need hex when you're a network engineer. All right, so let's convert 296 into hex. I'm going to put it up this way. How many times will 18? Okay.
With a remainder of 8.
With a remainder of 8, so put the 8 here. And we know there's a remainder of 8 because we multiplied 18 times 16,
Yeah.
subtract that number from here, and we had 8 left over.
It's 288.
16 will go into 18 one time, with how many left over? 2. 16 will go into 1 0 times, so we're finished dividing now, and this one then,
128.
so the equivalent would be 128. And if you were to plug it in under the number line, 128, 1 times 256 is 256, 2 times 16 is 32, 8 times 1 is 8, 10, 16, 296.
Yeah. Keep saying that.
Are we okay?
Do one more.
Do one more. Okay. 439. $439. times will 16 go into 439? 27. With what left over?
7.
7. 16 will go into 27? One time with what left over? 11, which is B. 16 will go into 1? 0 times with that one left over. So we've got 1, B, 7. Now, let's plug it in. 1 times 256 is 256. B is, and 11 times 16? 176. And 7 times 1? 7. 12,
19.
9, 7, 439.
I got that, but when I did it on the computer, it didn't put that 1. When I just did the, typed it in a decimal and transferred it to hex, whatever, it didn't put that 1.
Really? There must be a bug in that, that little program. Because do you see why you have to have the 1? If we stop right there, we've got 183? 4? 3.
Yeah, 3.
But you see how to do it this way, right? Right?
Yes.
Okay, all right. So that doesn't mean the computer made a mistake. Who made the mistake? The person that programmed the software that's in there. Did it get all the others?
It got all the other ones, yeah.
But it left the 1 out?
Yeah.
That's all. Okay, does everybody feel comfortable converting from decimal to hex? Sorta? Semi? Do one more? Go higher? Okay. $5,023. Convert that to hex. You asked for it. Bless you. Did you check it? Plug it in and go back and check it. Bless you.
Appreciate it.
how many times will 16 go into 5,023?
313.
313. And what's F? It's a 15?
Yes.
Okay, and 15 is F. 16 will go into 313. 19? 19 with what left over? 9. 16 will go into 19 one time
3.
with 3 left over. And 16 will go into 1 0 times with that 1. So it should be 1, 3, 9, F. All right, let's check it and see. 1, 3, 9, F. Okay. No, that's not right. That can't be right.
Give it a 1.
That's correct.
After the last,
16.
this is right?
Yeah.
Okay, all right, let's work it out. 1 times 4,096 is 4,096. What is 3 times 256?
768.
768. 9 times 16,
144.
144,
And 15.
and 15. All right. Oh, yeah. No.
Period 2.
Oh, period 2. Yep, okay.
Yeah.
You didn't get it? Okay, where did we lose you?
How to.
How do you check?
How do you check it?
Go.
Did you get this number, 139F? No? Okay, well, let's go over it again. Well, no, I won't do that. 5,023. Because 16 is the base, that's what we're going to divide by. 16 will go into 5,023, 313 times. Okay, so put that number here. And then what is 16 times 313?
5,008.
5,008. So what is 5,008 from 5,023? 15. 15's left over, so we've got to put the remainder right here. And 15 in hex is F. So then we're going to keep going. 16 into 313, 9, 19. And what is 16 times 19?
304.
304. Subtract that from here,
9.
and you've got 9 remaining. 16 will go into 19 one time. 1 times 16, 16. Subtract that from 19. You've got 3 left over. And 16 will go into 1
0.
0 times. So whatever is in this little box is the remainder. So then we've got our 139F. When you plug that in and we do all the multiplication and addition, we come up with 5,023.
So you always want to divide by 16?
Always, because that's the base. You can do that in any numbering system. You just divide by the base.
Okay.
Okay, we could have divided by 2 in binary, because 2 is the base.
So, okay. Okay.
Okay?
Okay.
When you're going from decimal into any other numbering system, divide by the base, save the remainder, you've got the answer.
So 16 is always going to be base. It's never going to change.
Not in hex.
Not in hex.
Yeah, in hex, it's always going to be 16. Always.
How did you check it again?
So, go ahead. Go ahead.
Go ahead. When I got this number, I plugged it in under my hexadecimal number line, and then you multiply this times that. So 1 times 4,096 is 4,096. 3 times 256
768.
is 768. 9 times 16,
144.
144. And 15 times 1 is 15, and then you add all of that.
So how is 15 L?
Okay?
I don't get it.
Okay. Hexadecimal allows us to use 16 digits. But it says you can only use, you can't use 1, 2 digits, you've got to use a 1. So in hex, those 16 digits are 0 through 9, and then instead of 10, we've got A, B, C, D, E, and F. A is 10, 11, 12, 13, 14, 15. Okay? Yes, sir?
So, 256 and 4,096, those are just the number line.
Those are just the number lines. Somebody multiply 4,096 by 16 real quick.
65,536.
65,536. That's the next number in the number line.
Okay.
And then we'd take this number, multiply it by 16 for the next number.
So those three after the 16 were never the base, that's just the number line.
This is just the number line. Yeah.
That's why I got confused.
Oh,
So
okay.
you don't ever divide anything by nothing except for 16 and
16, because that's the base. And this is always going to be our number line in hex, just like 1, 2, 4, 8, 16, 32 is the number line in binary.
Binary.
Yeah.
How far would the number line go?
For me,
I mean, for,
for the test, probably no bigger than that. Okay? Now, on homework, you may have something bigger than
For
that.
the final,
But-
is it gonna be bigger?
No,
Okay.
no, it's not. All right, yes.
Another use for hexadecimal is to represent the country deficit.
Oh, okay. Otherwise, you just couldn't print it, huh? Okay, do we feel a little better? Yeah, you're gonna do some homework on it. Okay, so now you can convert from decimal to hexadecimal. What if I ask you to go the other direction? Yeah. Now, remember where you are and where you're going. These last few problems we've been doing, you were in decimal going to hexadecimal. So we divided by 16, saved the remainder, and that was our answer. Now we're in hex. We're already in base 16, and we're going to decimal. So if I give you a 7, what is a 7 in decimal? You're right, 7. Remember, because everything up to 9 is exactly the same. What about a C? 12. Oh. I've got letters on the brain. 12.
So in decimal, it won't be better.
No, no. Where are we?
That would be.
We're already in hex, aren't we?
Yeah, that would be good.
Take this number, just like we did when I gave you this. When I gave you a binary number and said, give it to me in decimal, what did you do? You plugged it in under the number line, didn't you? So here, when you're in hex going to decimal, you do exactly the same thing. Once you pass F, whatever you've got, plug it in under the number line. 1, 5. 1 times 16 is 16. 5 times 1 is 5. And what do we have? 21.
Do it again.
Okay.
15 is X.
No. Remember where we are. If we were going from here to here, yeah, 15 is F. But we're already in hexadecimal. We're in base 16.
But you can't have 15.
You can have 2. For the numbers that we can use to represent every other number, we can only use 0 through 9, A through F, for those 16. But once we use those 16, we can use it. Remember, we had a 1, 3, 9F, or on that last one, we had 4 digits. You can have more than 2, but not in those 16 digits that we were able to represent. So when we get to 10 in decimal, that says you can't do that. So that's why they went to the letters because there's only one digit allowed here. But now, once you get into that, we can use any of those 16 to represent a number. All right, we're in hex.
Go, yeah.
So, that means we're already in base 16. We're going to take this number, plug it in under that number line, multiply whatever the number is under the number line, and then add, and that gives us our equivalent.
Under 16, what do you have? You have 1?
One.
16.
1.
Oh, so it's not 15, it's 1 and 5.
Yeah, because you're already in hex. All right.
So it's not 15, it's 1.
It's 1, 5.
Okay, gotcha. So
Okay.
you do 16 times 1 and 5 times 1.
Yes. Let's do another one.
Okay, I got you.
If I gave you A7 in hex and asked you to give it to me in decimal,
Would it be 10 cents?
171.
167.
107?
I've heard 3 different numbers. Let's see. Take this, add it, put it in the number line. What is A? 10 times 16, 160. 7 times 1 is 7, 167. Okay? You still have a look on your face.
Cause
Do what now?
I'm confused too.
Okay. Were you okay going from decimal to hex?
How did you get?
Yeah, but I want to know about A equals 16.
A is equal to 10.
A is equal to 10, remember? 0 through 9, 10, 11, 12, 13, 14, 15, and then this is in decimal. In hex, it's 0 through 9, 10 becomes an A, 11 a B, C, D, E, and F.
Yeah, I know that.
Okay?
And just like, so on the A, under the 16, put 10.
10 times that number is the 160, and then 7 times 1 is 7. Add those together and you've got your equivalent. Yes, sir.
So you multiply underneath the number line, and then you, whatever you get from underneath the number line, you add or multiply
You add. You multiply
underneath the
this
okay, gotcha.
and this, and whatever you get, then you add. Okay?
But you just put an A, for a minute ago you put 15.
Okay? Those are 2 different hexadecimal numbers. Yes, sir.
So anything under 9 is an A, right?
Anything under a 9?
Yeah.
You mean over a 9?
No, under,
Under a 9
yeah.
is the number.
No, it's just an A.
1 through 9 is A.
Yeah, 0 through 9 is exactly the same. 0 through 9 in decimal is 0 through 9 in hex. Once you get to 10 in decimal, then you go to the ABCs. 10 is A, 11 is B, 12 is C, and so forth.
You have any copies of number lines? We
No.
have some in the book, right?
Yeah, there's some in the book, in the booklet.
You tell me this is a grid?
Oh, no, that's what we're going to use to add and subtract.
Oh,
Let's do another one. All right, this number is going to be in hex. 2, 6. What are you going to do with the 2, 6?
so you 2 times 16.
You're going to put it under the number line. 2, 6, and then what are you going to do? 2 times 16 is 32. 6 times 1 is 6. 38.
38.
38, yeah, bless you.
Okay, I got you. Because y'all, when you say 38, you okay, I got you.
Okay,
I got you.
I'll try to remember not to do that.
I got it.
How are you?
Okay.
You're good? Is everybody good?
Yeah.
Anybody not good? Okay, so now you can convert from decimal to hex and from hex to decimal.
That seems
How long is it?
I'm sorry?
that's pretty easy.
Okay. Now we're going to, yeah, you just have to,
I was trying to take notes and pay attention at this time,
yeah,
but I,
you got it. All right, in your packet, You have a hexadecimal addition and subtraction chart. Hopefully you brought your packet, since I asked you to do that. Who did not? Y'all aren't gonna admit it, are you? Okay, we have one on the soul back here. Anybody else? Everybody else has it. Okay, you need to find in your packet the hexadecimal addition and subtraction chart that looks like this. It's a grid of a lot of numbers. Yes. It says up at the top, hexadecimal addition and subtraction chart. Now, you will notice down the left-hand side, there are the numbers 1 through 9 and A through F. Where have we seen those before?
Hexadecimal.
Hexadecimal. When you look across the top, from left to right, you see 1 through 9 and A through F. And then under the little bars, we see all sorts of numbers. This chart has already been converted to hexadecimal. You may use this on the test. So, see, I'm not so mean. All right. If I were to ask you to add 7 plus 2, I know you can do that in your head, but let's not. I want you to use the chart. To add, using this chart, you find one number at the top, one number at the side, and where they intersect is the answer. So find the 2 up here, the 7 on the side, and where do they intersect? 9. Does everybody see that?
Yep.
Now reverse what you just did. If you found 2 at the top, find 7 at the top and 2 at the side. What is the answer? 9. Same thing. In addition, it doesn't matter where you find what. Okay? One at the side, one at the top. Where they come together is the answer. All right, let's do another one. Oh, I erased one. No, I didn't. Let's do... $3B plus 9, 6. Now, you're going to do just like in any other addition, you're going to go right here. You're going to go to this column first. So find B at the top, 6 at the side, and where do they intersect? 11. What is 11 in hex? Oh, wait, no. We're already there. 11. We put down the 1. We carry a 1. Start adding from the top. What is 1 plus 3? What is 4 plus 9?
D.
Look on the chart. D1 is the answer. Let's do it again. B plus 6?
11.
So let's put down a 1, carry a 1. Start adding from the top. 1 plus 3
4.
is 4. 4 plus 9 is D. We okay? Let's do another one.
So why do you switch it up? I mean, is there a,
Switch what up?
are you switching it up as far as?
Oh, this?
Yeah, the way that you have it set up there, is there an application?
No, we're just adding 2 hexadecimal numbers.
So there's no program or anything?
No, I'm just taking 2 hexadecimal numbers and we're adding them together. Okay?
Do that one again.
Do this one again? Okay. All right, look at your chart. And you're going to start on the far right-hand equation. So this column. Find B at the top, 6 at the side, and where do they intersect? Okay, so you put down a 1, you carry a 1, just
Oh,
like
the
you
B
did.
and the 6 are like 1 together?
Well, it's one number, the B is one number, the 6 is one number.
Oh.
All right, now what is 1 plus 3 on your chart?
On here?
Uh-huh. 1 plus 3?
4.
4, and then 4 plus 9 on your chart?
D.
D. And that's your answer? Yes, sir.
Okay. Well, we get something wrong when we put 13, because D is 13.
Yes, you will get something wrong. Now, that's a good question. He said if you didn't put D here, if you put 13 there because D is 13, look what happens. D1 is what? 16 times 13 is 208. 1 times 1 is 1. So that is 209. But if we do 13, 1, 1, 3, 1, 1 times 256 is 250. Yeah. So you just change the value of the number. Whatever you take off of this chart is already in hex. You don't have to convert anything. Okay?
So we could have used this chart the whole time we were doing the exercises.
Only to add and subtract. The others you've got, because these are already in hex, but you got to know what that B1 is.
I meant like when you were giving us the
Oh,
example
no.
of hex. Oh, okay.
No, it wouldn't have worked out that way. Okay, to subtract using that same chart, you always, 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 do I make my point? You always find the bottom number at the top of the chart. So I want you to find 3 at the top of the chart. And I want you to put your finger or your pencil or your pen on 3, and I want you to run it straight. Don't look left or right. Just run straight down that column until you find the top number. 3 at the top, straight down to a 7, and across to the left, what do you see?
4.
I see an 8.
Okay, 3 you're adding.
Subtract.
3 at the top. Okay. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Okay, we're going to find 3 at the top of the chart because that's our bottom number in the equation. Then without looking left or right, we're going to stay right here in this column and we're going to move all the way down. Let's see, this would be 2, 3, 4, 5, 6, 7. You're going to go straight down until you find the number you're looking for at the top, across to the left, and this is your answer. You're going to make a backwards L. I'm sorry?
Before,
Oh, you said
come down till you find that number.
Yeah, don't look left or right.
Yeah.
You're going to have blinders on to anything else on that chart. Straight down that column.
So it's 8.
No, you're adding. Yes. Okay. You find the bottom number, and anytime it's a subtraction problem, you find the bottom number at the top of the chart. So find your 3. Now keep your finger right there. Don't look left or right. Just go straight down that column until you find 7. Go across to the left, all the way. What do you see? That's your answer. Is everybody okay?
Okay, I always find the bottom number,
At the top of the chart, go straight down that column.
So we're not
2 numbers.
looking at the columns to the left.
No, no. You're looking,
They're like not there.
they're not there.
What if you had 7 minus 7?
Couldn't do it on the chart, could you? What is anything minus itself? Doesn't matter what numbering system you're in, what is anything minus itself?
0.
0. And on your homework, there's going to be one like that. Anything minus itself is always 0. Let's do another subtraction.
And you don't never give a negative number, right?
There will, we're just not going to. Yeah. C9. Okay, C9 minus B2. You're going to use your chart starting over here on the far right column.
One number two.
What are you gonna do?
Sorry.
You're gonna find what at the top of the chart?
Two.
2. Find your 2 at the top of the chart. Go straight down that column until you find the 9s. Cross to the left. Did everybody find a 7?
51-7.
Okay, and then B at the top.
One.
Down to a C, across to the left.
1.
1. Are we okay? So to add, you find 1 at the top, 1 at the side. Where they come together is the answer. To subtract, you find the bottom number of the equation at the top, go straight down to the top number, cross to the left, there's your answer. Does anybody have any questions? And that's it for today. Just don't go anywhere.
Oh, no, popcorn?
No popcorn. I'm sorry? Hang on.